welcome to Data Mining, a fundamental business process for the 21st century. My name's Tom Khabaza, and I'm from the Institute of Data Miners. This is the first of two lectures and covers the topic of what data mining is, how it relates to other disciplines with which you might be familiar, and what data mining can deliver. To place this lecture in context, it's part of a course on managing information with technology. Data mining is a technology and a process which turns data and information into value. This lecture makes few assumptions about your existing knowledge, requiring only general background of business and data. The goal of this lecture is for you to understand what data mining delivers to a variety of different types of business, to recognize common business goals with which data mining could be expected to help, and to understand the kind of benefits which could be delivered by data mining in respect of these goals. We can take different views of what data mining is. First, I'd like to look at this question from the point of view of an organization which might get benefit from using data mining. The first three lines of this definition give a general explanation of what data mining is to an organization. Line 1 indicates that data mining is a business process. Line 2 indicates that data mining is undertaken by organizations. And line 3 indicates that organizations use data mining to extract value from data. The rest of the definition gives examples of what kind of value an organization might extract. Line 4 mentions increased profits and efficiency. Line 5 indicates that data mining can be used to help manage risk. Line 6 that it can improve service. Line 7 that it can be used in formulating strategy. And line 8 that in broad terms data mining can be seen as increasing knowledge. One takeaway from this definition is that, as a business process, data mining is very broadly applicable. Organizations can use it to achieve a wide variety of goals. Secondly, I'd like to look at data mining, as it were, from the inside. What does it look like as a business process? There's no definitive answer to this question, but the definition here can help you understand those aspects of the process which deliver value. Line 1 of this definition conveys a crucial fact about the data mining process, that it is a process of using business knowledge. Without business knowledge, data mining cannot happen. Line 2 says something about the results of the process, that it creates new knowledge. Line 3 gives the different forms of knowledge that data mining can create. 3a says that it can be knowledge in a natural form. This means human knowledge, knowledge in the head of a person, which can be used by a person. 3b says that this knowledge can also be in an artificial form. But what does this mean? The idea of knowledge in an artificial form is a reference to predictive models. I will explain these in a little more detail in the next lecture, but for our purposes here, it means information in a computer system which can be used like knowledge in a business process. Line 4 says something about how the new knowledge is created. It's created by discovering and interpreting patterns in data. Interpretation is important here. Patterns in data mean nothing in themselves without business knowledge to interpret them. This definition ties existing and new knowledge together with data and patterns, which is the crux of data mining as a technique. Before we go any further, we should examine the relation of data mining to other concepts with which you may be more familiar. Statistical analysis is an important technique in many disciplines, because given the right data, it enables us to evaluate with mathematical precision the strength of a hypothesis. Statistics is often associated with data mining because much of the technology used by data mining is based on statistical concepts. However, to confuse the two disciplines would be an error. Statistics is fundamentally about evaluating existing hypotheses, whereas data mining is about creating new hypotheses. To put it another way, if we already know or think we know how something works, Statistics lets us check whether or how strongly these ideas match reality. Data mining is for situations where we do not know how something works, or do not know enough. Data mining allows us to get new ideas starting from data and existing knowledge. Another set of technologies commonly available to businesses are those grouped under the heading of business intelligence, broadly encompassing reporting techniques and simple visualization. BI technology is very useful when a particular relationship or set of relationships is under scrutiny. For example, a senior sales manager might ask for a breakdown of sales by product, geographical region, time, and personnel, thus getting an instant picture of sales performance and trends. Visualization helps to make otherwise dry information more immediately obvious. By contrast, data mining would be used where the key relationships are not known. For example, what factors drive sales? There may be tens or hundreds of factors to be considered, far more than could be included in any report or visualization. Data mining helps sift these factors and find the individual or combined factors which have important effects. This analysis would not be performed by the same sales manager, but this manager would use the insight generated by the analysis, the new relationships that have been discovered. Another term, which you may have come across in connection with data mining, is predictive analytics. This started life as an umbrella term, created in order to group together a set of techniques then regarded as closely related, namely data mining, statistics, and visualization. However, the usage has changed with time. Predictive analytics is now used to refer to complete business solutions with data mining or predictive modeling at the core. We might say that data mining is the predictive heart of predictive analytics. I'll now turn to the areas of business in which data mining most commonly delivers benefit. Data mining is applied to a wide variety of different problems, but there are two specific areas which represent the majority of its applications. The first is customer analytics, together with its close relative web analytics, and the second is risk management, together with its subfield of fraud detection. The most common application of data mining is in customer analytics, sometimes known as analytical CRM or customer relationship management. The key concept here is that organizations use data mining to help them understand their customers, predict their behavior, and forge stronger and more profitable customer relationships. The first stage in this process is often segmentation, discovering through data mining what different types of customers the organization has, and inferring from these the market segments which are or could be targeted. The resulting segmentation can then be used as the basis for marketing and further customer analysis. Because customer analytics is frequently used to achieve marketing goals, a key type of analysis is response modeling, discovering who is most likely to respond to a given marketing campaign. This may be used at a high level to guide marketing strategy, or it may be used at the detailed level to select individuals to target with a specific marketing message, or to select the delivery channel most likely to succeed. Another very common type of analysis is attrition modeling, when a company or industry has a significant problem with customers who leave the customer base. Attrition modeling is used to understand why this is happening and to what kinds of customers. Again, this may be used at a strategic level to reduce customer attrition, or at a detailed level to target retention campaigns towards the customers most at risk. It should be noted that risk is not the only factor to be taken into account in customer retention activities. The profitability of the customer is also a key factor in determining how strongly the organization needs to retain them. On the positive side is customer growth modeling, used to help target upselling and cross-selling activities. From previous behavior and other data, we identify those customers who have potential for growth. Note that there is no single formula, no strategy or set of models that applies to every customer analytics situation. Each market is different, each organisation is different, each project is different. A key skill of the data miner is to work from the business situation to data mining and modelling activities which will help achieve the business goals. One very important subsection of customer analytics is that where the marketing and customer contact are via the web channel. Both internet marketing and e-commerce face unique challenges. On the marketing side, it's important to discover which online marketing activities generate the traffic that results in business. On the sales side, how can web traffic be converted into business? What are the barriers to individual sales? How can we increase the conversion rate of visitors who become customers? Underlying web analytics is the challenge of data. Web traffic generates data very rapidly, and the sheer volumes of data involved present unique challenges to customer analytics. The second most common application area for data mining is the broad one of risk analysis and management, including fraud detection. Risk management is important in every business, but is particularly formalized in the financial services industry, where requirements for risk management are enshrined in the regulatory framework. Here, risks are divided into credit risk, the risk that somebody will default on a debt, market risk, the risk of loss due to market movement, and operational risk, the risk of failure of organisation and process. Partly because of financial regulation, but in any case as an element of sound business practice, it's important for organisations to measure the risks they take and act on a sound understanding of those risks. Data analysis plays a key role in analysing risks of all kinds, and data mining is particularly useful when insight into sources of risk is required and when risk assessment needs to be integrated into operational systems. One specific form of operational risk is the risk of loss through fraud, and a great deal of technology has been developed to help organisations detect and prevent fraud that is buried in large volumes of transactions. Detecting fraudulent or suspect transactions rests on two types of recognition. The first is to recognise patterns of fraud that have been seen before. Spotting the similarity of a transaction or pattern of transactions to those involved in previous known cases of fraud. The second is to spot anomalies which represent types of fraud which have not been seen and detected before. Alert systems are commonly applied to detection of the first type, where business rules are used to define behaviours that should be regarded as suspicious. Data mining is used to tune these alert rules in the light of historical data and outcomes, and also to discover significant combinations of alerts. Data mining, in the form of anomaly detection, can also spot patterns which have not been seen before, by detecting situations which are divergent from the norm. After investigation, this may extend our knowledge of fraud and thus the patterns which can be defined in the business rules. This kind of data mining forms a complement to alert systems technology in fraud detection. So far, I've talked about data mining goals in a general way which will apply to different kinds of organisations. However, different industries have different questions which are typically asked, and goals which they wish to achieve through data mining. One of the earliest industries to adopt data mining for customer analytics was telecommunications, perhaps because of the intense competition and high customer attrition rates experienced in the mobile phone market. The telecommunications industry uses data mining intensively for customer retention goals, or churn reduction, and for marketing in general. And many of the largest players in the telecommunications market owe their stature to a strategy founded on analytics. Telecoms also have a significant problem of fraud prevention. Very high volumes of call data are generated, and both alert systems and data mining are used to detect and prevent mobile phone fraud and theft. Another big user of data mining is the financial services industry. Banks and other kinds of financial services use data mining intensively for marketing purposes. Banks also have very stringent regulation in terms of risk, and risk analysis using data mining forms an important part of best practice in measuring and controlling risk. Because of their intimate relation to financial transactions, banks also use data mining extensively to detect and prevent fraud and money laundering. The retail sector is also a heavy user of data mining, with a particular angle on customer behaviour. Offline retailers have a great deal of information about the combinations of products which their customers buy. Typically, basket analysis helps understand customer behaviour and optimise sales and logistics. In addition, where this data can be linked to individual customers, retailers benefit greatly from the ability to analyse and predict the effects of specific campaigns and have an impact on customer loyalty. Online retailers have all this and more. They can analyse behaviour within a shopping session as well as its outcome, and have huge potential to benefit from this. The pharmaceutical sector is of particular interest because it has two very distinct uses for data mining. It has the usual requirements for analytics in sales, marketing, and customer relationships. In addition, because scientific research plays a key role in commercial success in this sector, and because life sciences research is very data intensive, the pharmaceutical industry makes heavy use of data mining in the process of drug discovery. Last, but by no means least, data mining is used heavily in government for improving efficiency, managing risk, maintaining equipment, policing, fraud detection, border protection. The list is extremely long. Government represents, in this sense, not one, but a large cluster of industries, and its potential for benefit from data mining is correspondingly wide and deep. This is, of course, by no means a complete list of the industries that use data mining. We could mention energy and utilities, manufacturing, engineering, the military, charities, media, and many more. Almost any area of human endeavour now generates volumes of data about its business, and data mining stands to benefit them all. There are many other applications of data mining from which society derives great benefit. Data mining is used in law enforcement to improve crime detection and prevention and to help with the effective deployment of resources. It's also used widely in science, for example, to improve our understanding of toxic effects, and in genetics. More specifically, the application of data mining to genetic activation data enables early medical diagnosis and more effective treatment for some cancers. Data mining has also been used to reduce pollution incidents and to help understand and protect endangered species. Data mining is also used in engineering to help reduce breakdowns and improve equipment maintenance, and to improve quality in industrial processes. Finally, a slightly off-centre application. In our modern information-driven society, data itself can be a valuable product. Data mining is also used to improve data quality and to add value to data products. We've looked at what data mining is and several of the outcomes that it's used to achieve. Now I'd like to take a step back and tell you some of the general character of data mining applications. Data mining has the curious property that when applied to a business process, it usually creates multiple simultaneous improvements. Two examples, one from marketing and one from risk, illustrate this. Consider the application of data mining to a marketing campaign. By targeting the campaign more accurately, we can reduce the volume of the campaign and still get as good a result, thus reducing the cost of the campaign. But data mining results go further. Often, because the targeting is much more accurate, it's possible to reduce costs while at the same time improving response. That is, Though a smaller number of prospects are targeted, a larger number respond. With data mining, we can go further still. The targeting can be designed to satisfy multiple goals, which can include the ultimate profitability of the customer. Thus, we can have a situation where data mining simultaneously reduces costs, increases response, and improves the quality of respondents. Outcomes which might previously have been thought mutually antagonistic. The second example is from risk management, specifically the risk that an insurance claim is fraudulent. Typically, claim processing takes place in a number of stages where information is checked and risks assessed. Often, all claims go through the same time-consuming process, which means delays for the customer and is effort-intensive, leading to lower profits for the insurer and higher costs for the consumer. When an insurer uses data mining to help assess risk, the situation can change dramatically. Low-risk claims can be assessed and processed very quickly, leading to improved service to customers. Fraudulent claims are detected more easily, leading to fewer unnecessary payouts and lower costs to the insurer. But even better, because many of the checks can be automated and also fewer checks are needed for low-risk claims, the claim checking effort is greatly reduced, leading to even lower costs to the insurer and ultimately also to the consumer. So we have simultaneously improved the profits of the insurer, reduced the costs to the consumer, and improved service to the consumer. Again, three goals which might normally be viewed as mutually antagonistic. This character of data mining solutions to help achieve multiple conflicting goals simultaneously is more than a win-win scenario. We call it win-win-win. Now, these are strong claims. How can data mining achieve what was previously impossible? There is a simple way to explain this. Data mining and predictive analytics solutions create value for business processes by making them smarter. We can also say a little more about how this is achieved. Business processes are founded on business knowledge. By enhancing that knowledge, data mining enhances the process. In one particular respect, data mining can make huge improvements to a business process, that of recognition. Whether it's recognizing an opportunity or a risk, a predictive model introduces knowledge intensively into a business process. Lastly, we can say that data mining is able to do this because it does something businesses have always done, but does it better. That is, learning from experience. In the past, learning meant knowledge in the head of the operative. Now, it also means using the organizational memory which is founded on data. This is why data mining is a fundamental business process for the 21st century. So this lecture has taken us full circle. I started with what data mining can achieve, moved on to where it's usually done, and ended with how all this is possible. In the next lecture, I'll concentrate on the how data mining is performed, how it integrates into a business in order to deliver results. This concludes part 1. Thank you for listening.